We are continuing to do the integration of rational functions by using partial fractions. The last case I want to talk about is when the denominator has irreducible quadratic factor. So we have a rational function, p of x over q of x. The denominator contains an irreducible quadratic factor that is ax squared plus bx plus c when b squared minus 4ac is less than 0. This condition just means this cannot be factored into the linear factor because this will make the solution complex number. Let's do the example. We want to evaluate integration 26 over x minus 1 times x squared plus 25 dx. The fraction 26 over x minus 1 times x squared plus 25 will be broken into two pieces. The first one will be from x minus 1, so we will write a over x minus 1. The second one has degree 2 polynomial. In that case, the numerator will be written as bx plus c, which means just one less degree. The remaining step will be very similar to what we did in the previous class hours. The common denominator is x minus 1 times x squared plus 25. So a over x minus 1 times the missing factor is x squared plus 25 over x squared plus 25 plus the second fraction bx plus c over x plus 25 times the missing factor was x minus 1. So we will multiply that to the numerator and denominator together. So by doing that, we have common denominator, and the common denominator is x minus 1, x squared plus 25. Before we combine the like term, we have to distribute. So a x squared plus 25a plus we will do FOIL. So b x squared minus bx plus cx minus c. So that equals x minus 1 times x squared plus 25. And then we think about degree 2 terms. The coefficients are a and b. So a plus b and x squared. And then these two are degree 1 terms. So plus minus b plus c x plus constant term is 225a minus c. When we compare the first fraction and last fraction, in the first fraction, the numerator consists of only one term, 26. So this 25a plus c will become 26. But in the first fraction, there is no x squared or x related term. That makes a plus b equals to 0 and minus b plus c equals 0. So we are getting 3 equations. So we have 3 equations, a plus b equals 0, and minus b plus c equals 0, and 25a minus c equals 26. Let's say this is a, this is b, and this is c. So from the second one, we can say that b equals c. The reason we do b first is if we change c to b in the third equation, we can have only the variables a and b. And so we can make the first and third equation into the equations with the same variable. So what I want to write here by using this fact is 25a minus b equals 26. And then what I want to do is we want to combine these two. So I will write this equation right below that equation. And then we will add vertically, then 26a equals 26. So that means a equals 26, a equals 1, 26 over 26, which is 1. So that means b equals minus 1 because a plus b equals 0, right? And then b equals c, so we have c equals minus 1, right? So we got a, b, and c. Any questions so far? So the given integration, 26 over x minus 1 times x squared plus 25 dx can be written as integration. A was 1, so 1 over x minus 1 plus b is minus 1 and c is minus 1, so minus x minus 1 over x squared plus 25 dx, right? And then we will split that into two terms. So we have integration 1 over x minus 1 minus x over x squared plus 25 minus 1 over x squared plus 25 dx. So what we will do will be, of course, the first one is something to do with natural log, and then second one, substitution. The third one is related to inverse tangent. Let's do x over x squared plus 25 dx. The degree of the numerator is 1 less than the degree of the denominator. So we can think about the substitution method. If we put u equals x squared plus 5 squared, then du equals 2x dx. So x dx equals 1 over 2 du, right? So we can rewrite that as integration 1 over u du. X dx is 1 over 2 du. So I will write 1 over 2 here. So that is 1 over 2 natural log of absolute value of u plus c. So that is 1 over 2 natural log of u is x squared plus 5 squared plus c. Any question? So the next thing we have to do is integration of 1 over x squared plus 5 squared dx. We just use the formula, then that is 1 over a, so which is 1 over 5, tangent inverse of x over 5 plus c. That is just from the formula. The formula I used was dx over x squared plus a squared is 1 over a, tangent inverse of x over a plus c. So we will combine all of those together. So integration of the first term is natural log of absolute value of x minus 1. The second one is 1/2 times natural log of u, but there was minus, so I will keep minus in the middle. And then that is 1 over 2 natural log of absolute value of x squared plus 5 squared minus came from here, and the last term is -1/5 tangent inverse of x/5 plus c. Any question about this problem? Are you ready for the next subject? The next subject is about the different type, which is very implicit. So those will be pretty tricky to figure out. So other type. We want to evaluate integration square root of x plus 36 over x dx. If you look at the pattern, then there is a problem because degree of x here, and when we ignore this square root, the degree of x in the numerator and denominator are the same. So if you put like x, the u equals x plus 36, then dx is dx, and that doesn't help with the x in the denominator. We cannot get rid of the x in the denominator. But if you just forget this part, and then this degree is a half of this degree. So what we will do in this case will be, instead of putting u as x plus 36, we will put u as square root of x plus 36. And then we will think about square of that. So u squared equals x plus 36. Then what we know is 2u du equals dx, right? So in this case, x can be written as u squared minus 36. So by doing this process, the degree in the denominator will be 2 and degree in the numerator will be 1, right? So we can think about other, just so we can make progress. So the given equation becomes the numerator u and the denominator x becomes u squared minus 36. Dx was 2u du. And we can write 2 in front of integration, and then we multiply these 2, then we get u squared over u squared minus 36 du. This time, what happens here is we could get rid of square root, and that is just a rational function with the same degree. If the denominator is not a higher degree, then what we will do will be, we will just think about the long division. But in this case, the fraction is particularly simple. So instead of doing long division, we will just add and subtract minus 36 and split the fraction into two different fractions. So that is 2 times integration. We will split like this. Then that becomes u squared minus 36 over u squared minus 36 plus 36 over u squared minus 36 du. So this fraction is 1, right? So we have 2 times integration, 1 plus 36 over u squared minus 36 du. So by why did we add 36 to the numerator? Because we want to split that into like this. Otherwise, you can just do long division u squared and u squared minus 36, and then you have 1, and then u squared minus 36, and if you subtract, then you will get 36. So you have the same results like this. So now we are getting to the familiar format. So we have 36 over u squared minus 6 squared. So we will use partial fractions. So 36 over u minus 6 times u plus 6. We split that into two terms. So a over u minus 6 plus b over u plus 6. So that is u minus 6 times u plus 6, a times u plus 6 plus b times u minus 6. So denominator is u minus 6 and u plus 6. And then let's just distribute so that nobody becomes confused. AU plus 6A plus BU minus 6B. And then we will gather the like terms. So U related terms and then constant terms. So it becomes A plus B times U plus 6 times A minus B over U minus 6 times U plus 6. And then as we have been doing, we have to compare the last fraction with the first fraction. So this one will be 36. And there is no u related term. That means coefficient of u equals indeed 0. So a plus b equals to 0. And the other one is 6 times a minus b equals 36. So we divide by 6 on both sides. Then a minus b equals 6. So from here, we get a equals minus b. So a equals minus b. So here is minus b. So minus b equals 6. So minus 2b equals 6. And we divide by minus 2 on both sides. So b equals minus 3. And then we use this. That means a is just dropping minus sign in front of 3. So we got a and b. Any questions so far? So we just did a common calculation in college algebra to make things easier. So let's go back to this point. Then that'll be 2 times integration 1 du, that is the first term, plus integration 36 over u squared minus 6 squared du. And then what we can say is, so when we integrate the first one, it is u, plus we already calculated and we obtained a equals 3 and b equals minus 3. So we will use that information to write the integration as 3 over u minus 6 du minus integration 3 over u plus 6 du plus c. So a is 3 and b is minus 3. That is applied here. By doing that, we have natural log as integration. So that is 2 open parentheses u plus 3 times natural log of absolute value of u minus 6 plus minus 3 times natural log of absolute value of u plus 6 plus c. So we can just expand that out. Then we have 2u plus 6 natural log of absolute value of u minus 6 minus 6 natural log of absolute value of u plus 6 plus c. So it goes like this. We go back to the starting point substitution to convert the expression into x-related expression. then u should be written as square root of x plus 36. So that is 2 times u is square root of x plus 36 plus 6 natural log of absolute value of square root of x plus 36 minus 6 times natural log of absolute value of square root of x plus 36 plus 6 plus c. So that is the final answer. Any question? Let's do one more problem for today. The next problem is evaluate integration x cubed over 5th root of x squared plus 7 dx. We will use the similar trick. Unfortunately, x cubed is higher degree than this one. But maybe you may imagine x cubed can be split into x squared times x dx. But anyway, in this case, what we want to do is we want to put u equals 5th root of x squared plus 7. Then we raise to the 5th power, then u to the 5th power equals x squared plus 7. So we can say that x squared equals u to the 5th power minus 7, right? And if you differentiate, then we have 5u to the 4th power du equals 2x dx. So what I said was probably you can imagine that this one can be split into x squared times x. And then x squared can be converted into u related thing. The denominator becomes u, and the x dx will be 5 over 2 u to the 4th power du. So let's combine all those things. So x cubed over 5th root of x squared plus 7 dx equals integration x squared over 5th root of x squared plus 7 x dx. So we just do substitution to eliminate x-related things as well as the 5th root of something. And then it'll convert the given form into the rational function. So x squared is u to the 5th power minus 7 over, we put 5th root of x squared plus 7 as u. So over u, x dx, we divide by 5 on both sides. Then x dx equals, we divide by 2 on both sides. Then that is 5 over 2 u to the 4th power du. So x dx is 5 over 2 u to the 4th power du. So we think about this one and this one, and then u cubed. So 5/2 integration. Let me just write down. So 5/2 was the number here, and I put the number here. And then we have u to the 5th power minus 7 times u cubed du. So that becomes 5/2 integration u to the 8th power times 7 u cubed du. So it is nothing but a polynomial form of the integration after the conversion. The tricky part is the figuring out the strategy when the format is like this. So that means 5/2, we are doing the term by term integration. Then that is u to the 9th power over 9 minus 7 times u to the 4th power over 4 plus c. So we do distribution, then we have 5/18 u to the 9th power minus 2 times 4 will make 8, and 7 is 7/1, so 5 times 7 will be 35 u to the 4th power plus c. And then we are going back to the starting point. Let's rewrite this one as open parenthesis x squared plus 7 to the 1/5 power. And then that is 5/18 times x squared plus 7. And there is 9th power. When we multiply the exponents, we get 9/5 as exponent, minus 35/8. And x was x squared plus 7. This is the power. 4 times power 1/5 will make 4/5 plus c. So any question? So this is the end of 7.4. There are some tricky problems. So any question about this? You will take an exam next Monday. The exam range will be up to 7.3. As I said, you have to study the lecture note and remember all the formulas and also problem solving strategy. If you start to be confused with the formula, especially if you're confused with the formula, and if you start the problem wrongly by applying the wrong formula, then you cannot get any point. So if you made some minor mistake, then it'll be just a subject of deduction. But if you just I think if you just forgot the formula and started wrong, then you will not get any credit. I think I said there are 6 questions, right? And so it's important that you just master all the formulas and also problem solving strategy. You always remember that the exam hour is only 50 minutes. And so some problem, 1 or 2 problem, maybe a little bit longer. However, those problems cannot be overly complicated, but at the same time, speed is also important. And what I was saying was you have to study the lecture note. And so focusing on the lecture note and write the formula down, and so that you are not confused with the formula. And also you write the examples, and the understanding is very important. After you understand, to take the exam, that is about whether you master the subject. You should remember how you worked out the problem. You should be able to do it without referring to anything. So you write the examples, and then of course you have to go through all of those once, and then after that you will take those examples I presented like exam problem, and just to try to solve it by yourself without seeing the lecture note and compare the answer. And if you couldn't do it, then you just have to practice it. And so just use the examples in the lecture note as your guidance. And so when before the exam, if I were you, what I will do would be I will just list the examples also, and I will just go through the example and strategy. And when you see the pattern, you should be able to identify the strategy and formula you have to use. And so as long as that part is done, and if your background is good enough, and so if you don't make a problem with simplifying the fraction and the how to calculate the exponent and do prerequisite things, then I think you should get pretty good score, because your strategy is correct, and you're applying the correct strategy with the correct formula. Yeah, it is. I think there are 6 sections, right, in the exam. It'll be 6.1 to 3. Yeah, it'll be from chapter 6, 6.1 to 3, and chapter 7, section 1 to 3. And you can imagine that the problems are chosen one from each section. Any question? As I said, you will not be allowed to use your the formula sheet or any help, and you will be using just only very basic scientific calculator without having any memory feature, and graphing calculator is not allowed. Any other question about the exam? Hopefully you study hard for the exam and do well on the exam. So see you on Monday. Okay, have a nice day.